Yes, welcome to DC Economics. So today we are going to look on increasing and decreasing function. So a function is an increasing function if the value of the function increases with an increase in the value of the dependent variable. So a function is an increasing function if the value of the function increases with an increase in the value of a dependent variable. For example, y is equal to function of x. This is an increasing function if x1 is greater or equal to 2 or is equal to the function of x1 is greater than or equal to function of x2 for x1 and x2 that summation the domain of the function. So a function is an increasing function if the value of the function increases with an increase in the value of the independent variable. As you observe the function that if x1 is greater than 2 or function of x1 is greater than or equal to function of x2 for x1 and x2 a summation of the domain of the function. Now what about a decreasing function? Now let's look on decreasing function. So similar to the value of the increasing function, a function is decreasing function. A function is decreasing function. A function is a decreasing function with a fall in the values of an independent variable. So the value of a decreasing function increases with a fall in the value of an independent variable, decreasing with an increase in the value of an independent variable. So it increases with a fall. The value of an independent variable. Is a fall of an independent variable and decreases with an increase in the value of an independent variable. So similar, the value of decreasing function increases with the fall in the value of an independent variable, decreases with an increase in the values of an independent variable. So for example, x1 is greater than x2 and the function of x1, function of x2, so for that x1 and x2, these are the domain of the function. The domain of the function. So what you need to understand over here is that in order to solve these issues, to check out on whether it's increasing or decreasing, we need to apply the derivative of a function. That can be applied to check whether a given function is an increasing function or decreasing function in a given interval. So actual derivative function is actually applied. So the derivative of a function can be applied to check whether a given function, is decreasing, is an increasing function or decreasing function. So if you apply the first order derivative of the function, if the sign of the first derivative of a function like this give you a positive result or give you a negative or a positive sign, it means that this actually implies the value of the function the value of the function is increasing. So when you solve the first derivative and obtain the positive sign for your result, now it implies that the value of the function is increasing. And vice versa is true when you solve the dy over dx, the first order derivative of the function, and thereafter you obtain the result is negative results. This will imply that the value of the function is decreasing function. So graphical, you may illustrate these functions how they appear. You may show out the increasing function, how it looks like. Let me show the graphical over here. So when you sketch like this, let me try to show the illustrated mark here, this place, something like this. So actually, this is a function of x2, and this side here, let's take it be a function of something like this. So we take out these values over here, as you observe. So this first graph represents out the increasing function. This represents out the increasing function. In the right hand side graph represents out a decreasing function. A decreasing function, as you can observe. So as you can observe here, the increasing function actually consider to take out the values of x1 that is greater, x1 as greater or equal to 2, or the function that is taking out the function of x1 is greater than or equal to the function of x2 for x1 and the x2. Now from this function you can observe this is called the increasing function. As you observe, when the independent variable function increases, also the independent variable, when the function given variable for x2 increases, also the function of x2 or x1 increases, going on the same direction. But you can observe here this is decreasing in terms of scale, since the independent variable, when it decreases, it actually leads to the given variable function of x to increase. So it shows the increasing function as we observe. So after looking, so now let's go to an example. Now you can check whether the function check whether the function 3x cubic plus 3x squared plus x minus 10 is increasing or decreasing. Is increasing or decreasing. Solution. Now from the given equation over there, 3x cubic plus 3x squared plus x minus 10, we apply the first order derivative of the function, that is d over dx. That will give you 3 times 3 is 9x raised to the power of 2 plus 2 times 3 is equal to 6x, then plus the derivative of x is equal to 1. Now when you derivatize negative 0 is equal to constant, that is equal to 0. Now from this given function, we can observe that the function is always positive because from this function, we may try to expand this function. Instead of write 9x squared plus 6x plus 1, it's like to say you write out 3x plus 1 raised to the power of 2. Well, when you expand this, it will be 3x plus 1 times 3x plus 1. That will give you the same results of 9x squared plus 6x plus 1. Now, since we've applied the first order derivative, and obtained the positive results, so we can conclude that, you may conclude that the function is always positive. So the function is always positive. The function is always positive. Because three x plus 1 raised of square is positive. Since the square of a real number, is always positive. Is always positive. Therefore, we may say that 3x cubic plus 3x squared plus x minus 10 is increasing. So, thank you for watching. This is DC Economics. I beg you don't forget to subscribe my channel and welcome to other videos. Bye bye.